Voice clear? Everything is okay? Everything okay? Voice and display? Okay, so start now. See, last time, first make a note before you start. One small note you make. See, each and everything I tell here, you should make a note. Then only the very purpose of this question is served. One small note first. See, so far means I think for this question, I solved 4 questions, I think, correct? I solved 4 questions. See, this is a common data. For this common data, that is, data is what? A beam cross section is, properties are given, width of flange, etc. given. Then it is told, question number 1, draw the stress distribution for when bending moment is some sagging bending moment, already over. Second question, same section, hogging bending moment something, over. Then next question, what BM will produce maximum compression of so and so? BM is sagging, so compression at the top. So find what BM will produce compression sigma 1 compression at the top. Don't buy at sigma 1. Top fiber stress is compression equal to given value, get M, and then find if for that bending moment what tensile stress will come. Next question, same thing, what hogging BM can be applied? No, sagging BM only. Sagging BM can be applied to control the not compression, tension. So sagging BM you apply, control tension, then what to do? Not control tension. They are not bothered about control. So will produce, you equate sigma to what? The given tensile stress, over. Now make a note. Suppose 5th question, I'll give 2 more questions now, so that, see, now don't come here now, nothing here, continue. 5th question, what hogging BM will produce maximum compressive stress of any random value, 140 Newton per mm square. Okay. Then what will be maximum tensile stress? This you have to solve. Answer I will give. Answer. Tell first. They told what hogging BM. So tension at the top now, compression at the bottom. Therefore, they want what hogging BM will produce compressive stress of how much? 140. Tell me, which fiber stress you have to make 140? First. Which one you have to take? 140. Sigma 1 or sigma 2 now? Which one 140 now? Sigma 1 or sigma 2? They want what hogging BM will produce compressive stress of 140. Which one you have to take? Sigma 1 or sigma 2? Fast. This all over last time. This is anybody who are absent last time, if they don't understand, their problem. But those who are, sometimes happens, due to some problem they cannot come. If they know subject, then it's okay. If subject is known, sigma 2. So answer will be for sigma 200. How much? 140. I'll give the answer. Corresponding BM will be 140. Answer is 380.3 kilonewton meter. And then they are asking for that BM, what is the maximum tensile stress? Answer. Second answer is 159.146 Newton per mm square. This is homework. You should do it now. Correctly do the question. Then only you get full control. Okay, start. Now, 6th question. Series of questions. What hogging BM will produce maximum tensile stress of anything 125 Newton per mm square over. What will then be the maximum compressive stress? Tell the answer now. Now you have to find such a BM so that tensile stress, hogging BM, how much will produce tension of 125? Tell me which fiber? Tell me which fiber? So your stress to be considered is top or bottom fiber. Hogging BM told tension they want to produce how much? 125. Which fiber? Top or bottom fiber? Fast. Which fiber? This much difficulty. No, you are not answering question. They are asking what BM will produce tensile stress of 125. So, top fiber. So, based on that one, find the bending moment. Answer. And stress I will give. Answer is Z1, 2.41. 302 kilonewton meter. Point something is there, leave it. 302.00 is there, leave it. 302 kN meter. At that time, they are asking what is the maximum compressive stress produced. Answer. 109.962. Okay. Solve all these 6 questions first. Those who are serious and want to learn and get complete grip on bending stress chapter, systematically solve all the 6 questions. Okay. Then, now write a powerful note. See, we solved 6 questions for this cross section. You write there. All the 6 questions. We are not bothered about strength of the material or how much tensile stress or how much compressive stress the material can sustain. We are not bothered about it. Simply question is, first time, apply a BM. First 2 questions. Apply a BM. What is the stress produced? And next questions. What BM will produce so and so stresses? That is question number 3, 4, 5, 6. So, in all the 6 questions, we never bother whether what is the material property, how much stress it can take, and also we never bother whether the stress produced is safe or not. It may be safe, may not be safe. Randomly stresses calculation, or I told money matter. Simply eat and pay the bill. How much money you have got does not matter there. How much you ordered there, bill will come. Pay the bill, with dignity, pay the bill and go out of the restaurant. Otherwise, they will take action. Whether you are having that much money with you or not, or you got extra money or shortage, they are not bothered. They told, your bill is so and so, pay it. Over. Full clear? Full clear, first. Full clear. This all statement you are right. We never bothered about limit. Clear or not? We never bothered about what is the property, what is the allowed stress for material, or how much stress is permissible. None of them we bothered. Okay, now make a note. Continue the note. Now we are going to 7th question. No, I am going to part 2. Part 2 of this question. You can do one thing. All those 6 questions, you write part 1 question. Then write the note. Part 1 is randomly bending moment. See, never ask, are you okay? How are you feeling? You never ask. Mercilessly apply bending moment. See, part 1, right here. But now we are going to part 2. In part 2, you have to ensure safety. We have to ensure safety, not randomly apply bending moment. When you apply bending moment, you have to observe there and see sagging or hogging. Whatever you apply, if you can talk, you have to talk with the material. Hello, material. How is your compressive capacity? What BM I am going to apply this BM? Can you manage it or not? Please tell me. If you cannot manage, I will reduce the bending moment. If you can manage, I may apply it more. Please tell me when to stop the bending moment. See, that is now you eat according to the money you have in the pocket. Now onwards, how much money you have got in your pocket, that counts. See, financially, money in the pocket. Here, now we are going to consider the permissible stress. Permissible stress is for material, remember. For example, steel. In bending, in working test method, bending we take 165 Newton per mm square when laterally what? Supported. Whereas, then in tension we take 150 Newton per mm square. For rivet solve, see, so shear, I think 100 for shop rivet, 90 for field rivet, bearing 300, 270, etc., etc. Or concrete, M20 concrete, stress we are limiting to 7 Newton per mm square. Or M50 is not allowed. M30 concrete, not more than 10. Mild steel, not stress more than 140 or 130 depending on diameter. Torque steel of grade FE415, stress not to exceed 230 Newton per mm square. FE500, 275 Newton per mm square. Timber beam, some timber beam, good quality, 16 Newton per mm square. Some timber beam, strong in compression or little weak in tension, limit will be there. Some strong in tension, weak in compression. Now we are bothered about the strength. That is, now you are going to consider a term called moment of resistance. So right, first definition, moment of resistance, in future short form MR. Moment of resistance of a beam cross section is the maximum BM cross section can resist. Maximum BM cross section can resist. Or you can also tell maximum allowed BM for the cross section. See, MR is not for the beam, it is for the cross section. Sometimes people will ask, what is the resisting capacity of the beam? You don't answer the question. You ask the question correctly. Not beam, span is not counted. For the cross section, some will tell span counted. When? Laterally unsupported beam. Okay, then length counts. Yes, length counts. But length counts based on the length. Finally, the stress allowed is for cross section only. I tell keep quiet. Don't argue with me. Then he will tell okay. So it is for cross section. Maximum allowed BM for the cross section or permissible BM for the cross section or maximum limit for the maximum limit for BM for the cross section. Now, one simple statement I will give you. First, understand that one. See, remember the word maximum is important. The word maximum is important. Now, see. Now, I will put one statement here. Simple language. Don't bother about this question. Randomly you know M equal to sigma into Z or sigma equal to M by Z. If you write this way, this is stress developed. Stress developed. M is the bending moment applied. Z is cross-sectional property. Over. Here, if we substitute for M, some bending moment, we get how much stress is developed. Stress is developed for that BM or due to that BM. Due to that BM. And here, permissible word will not come, like paying the bill for whatever you are eating. Nobody bothers how much money you have got. Simply, you ordered these items, pay this much bill. Now, just imagine, for a material, sigma, see, this is for the material. Some tension, compression, worry later. Sigma is not to exceed, I'll put a number, 100 Newton per mm square. That is the maximum permissible stress. So there is a material for which tension compression later stress is not to exceed 100 Newton per mm square. Okay. Now, suppose if you apply a bending moment of 20 kilonewton meter, imagine stress coming is, anything can come. M by Z will give you, say for example, I will take Z equal to some 10 units or anything. Stress developed equal to 50 Newton per mm square. Imagine. Tell me, safe or not safe? You see, sigma equal to M by Z. For the material, permissible limit is 100. You apply a bending moment of some 20 kN meter. At that time, a stress of 50 will come. This 50 is less than permissible limit of 100 Newton per mm square. Therefore, tell me, safe or unsafe? First, it is safe. Safe. That means, you write here, safe means the beam cross section can safely resist bending moment of 20 kilonewton meter. Yes, 20 kN meter beam can resist. Like you have 100 rupees in the pocket, bill comes to 50 rupees. Yes, you can happily pay 50 rupees and come out. Over. But that 20 kN meter is not MR. Tell me, it is not MR. Why? MR is the maximum BM section can resist. Therefore, it is not, 20 is not MR. It is a bending moment which is safe for the cross section. Cross section can resist it, but it can resist more. Suppose I make bending moment 20, 40, see, 39.9, stress of 99 point, divided by 2 andre, linear proportion, actually not required. Okay, 50 by 20 into 39.9, 39.9 into 2.5, 99.75 Newton per mm square. Still it is less than permissible limit of 100. Therefore, is 39.9 also is safe or not? First tell me. Is 39.9 is also safe or not? First. 39.9 also is safe or not? First you have to tell the answer. 39.9 also is safe or not? You have not answered. That is the old one. New answer. First. 39.9 also is safe or not? Because bill came 99 rupees 75 paisa. You have 100 rupees. Is safe. Still it is not MR, but it is very near to MR. Now, suppose I apply a bending moment of 40 kilonewton meter, stress will come exactly equal to 100, equal to limit of 100. Even now it is safe. Now tell me, suppose I increase the bending moment, stress will go beyond 100. Some items you ate in the hotel, bill came exactly 100 rupees. Yes, you have 100 rupees in the pocket. Yes, you are safe. Going home, go walking. No, you can't go by bus also. Okay, go back by walking. Or imagine vehicle, petrol is there. Now, is this 40 is the MR? Tell the answer. Is that 40 is the MR? Yes or no? I want yes or no. Is that 40 is MR or not? That MR, maximum BM, it can resist. Is it 40? First. Is that 40 is the MR or not? Yes or no? This is not time to decide. Is that 40 MR or not? I want yes or no. If you don't answer, what I can do? This much delay for answering. One, yes, that is the MR. So maximum MR is now. By chance you apply more than 100, more than 40, then when you divide by Z, stress will become more than 100. It is not safe. Therefore, MR, when you consider MR, it should be the maximum BM. For cross section can resist. Or if you have 100 rupees in the pocket, if you eat 20 rupees, that 20 is not the MR. It is, you can pay 20 rupees, no doubt, but that is not the maximum bill you can afford. So if you have 100 rupees in the pocket, the maximum bill you can afford or allowed for you is 100 rupees, that way. Therefore, I will not tell again and again, therefore, MR corresponds to, only once I'll put red color, very important. This is, I should be putting the red color because very important statement. Yes, right time, not getting red color. Right. Therefore, MR corresponds to that BM for which stress developed, means maximum stress only, stress developed, but developed reaches what value? Reaches what value? Stress developed reaches what value? Stress developed reaches what value? If the stress developed is less than the limit, it is safe, no doubt. It is not MR. MR is the maximum limit for which stress developed reaches how much? Stress developed reaches what value? Such a difficulty. Stress developed reaches. I am asking 10 times now. Question. MR is that BM, correspond to that BM for which stress developed means what stress we will discuss, reaches the permissible value, permissible stress, or sigma permissible. Sigma permissible, very important. Remember, sigma permissible for cross section. This is very, very important. Randomly you can't write. I will explain further. Okay, now I will give to make clear. Or see, if you apply random BM, stress is, you find stress by M by Z. So if you want MR, MR is M equal to sigma into Z, where the sigma is the permissible limit. Therefore, when you find MR, stress, furthermore important, maximum permissible stress for cross section. The term cross section is very important. So many people get confused here. For the cross section, see my RCC class, I always write there, maximum permissible compressive stress for the cross section, permissible stress in concrete for the cross section, maximum permissible tensile stress in steel for the cross section. I will tell you why it is for the cross section. If a permissible stress is given, blindly you cannot substitute. Problems are there. Sometimes it will create problems. Okay, now go further. So remember this formula for MR. Go further. I will give a simple example for you. Remember now, simple money matter example. Some will tell why money matter came. This will completely clear the concept for you. You write. Earlier, if you remember, I used to give money matter example in RCC hall. 2 persons going to a party, so many people are going for party, 2 are paying the bill, and understanding between them how much one will pay with respect to other. I am changing it now. That is there. See, just imagine a eating place, restaurant, where one is ordinary, one is AC class. AC means special. One is ordinary. Ordinary is what? Just you have to put self-service. Ordinary and also self-service. Other is AC, special. where service is there, surely charges are more. Just to understand, see here, the ratio is 133 by 117. That way I cannot put. To understand practically so that you give correct answer, I will just imagine for AC room, double charge. Double charge compared to ordinary. Compared to ordinary. See, some hotel where as you enter, you get ordinary session, where you have to buy a token, self-service, you have to go to the counter and collect whatever you want. Inside, AC room is there, posh, very posh. Sometimes it is there, see there, their cost is much more, double. Double so that you can easily calculate without calculator. Okay, now, that is double. If you eat, a coffee, if it costs 20 rupees here, it will cost 40 rupees there. One dosa, if it costs 50 rupees here, it will cost 100 rupees there. Over. Now, I will tell you what is this AC and etc. little later. Now, imagine two people are going. One of them is A, other is B. Okay, I will do one thing now. A, I will write smaller. B, I will write bigger. See, A, B, bigger. That means this person B has more money. He is little rich. Rich. A is ordinary. Ordinary. Two people are going. See, B for big. He is little rich. Now, one understanding is important. See, when you apply bending moment, stresses developed at top and bottom fiber are connected by sigma 1 by y1 equal to sigma 2 by y2, or sigma 1 is sigma 2 into this number, sigma 2 is that number. See, this is more than 1, this is less than 1. Or, you can imagine here, cost in the AC is twice of cost in the ordinary section, self-service section. Or, you can tell other way, cost in the self-service section is half the cost of AC. Both are same. AC room cost is double the 2 times of this one. Or, that if you compare, if you go to AC, you have to pay twice. Or, someone goes to AC, how much he pays there? Self-service wing, you have to pay only half. Over. Now, here, ordinary person goes to, A goes to ordinary side. He goes to ordinary part, ordinary section of hotel. He will go to AC part, AC, that is posh. Posh. But remember, whether one side is compression, one side is tension. But both together will create the resisting couple. Remember, only one force cannot create a couple. To create a couple, how much compression force comes, tension force comes, and then they will create a couple. By, see, two-wheeler, single wheel cannot go. Of course, some will tell wheelie. Wheelie means they should be short on the road. See, someone tells, no sir, single wheel can go. Illegal. It is not allowed. Suppose you lock one of the wheels. Ordinary citizen cannot drive the vehicle. Why? For vehicle to go, both wheels should run. So, if the front wheel goes at 60 speed, then what about back wheel? Back wheel also will go at 60 speed. How much vehicle will go? Vehicle will not go at 120 speed. Tell the answer. Front wheel, two-wheeler. Front wheel goes at 60 kmph. Then back wheel also will go at 60 kmph. Tell what speed vehicle will go first. Front wheel 60, back wheel 60. What speed vehicle will go? 120 first. What is the, in what speed the vehicle will run? Is it 120? First. Front wheel speed is 60. Back wheel speed also 60. What speed vehicle will go? 60 only. You cannot tell, see, if that is going 60, this is going, if both are going 60, vehicle will go at 60. So when you apply the bending moment, tension, compression, both are required. Only tension or only compression cannot create couple. They together will create couple. See, if I apply only one force, you cannot rotate. you require two forces opposite. One simple example I'll give you. See, vehicle, car driving. This is the shaft or hub, what you call. See, usually two people drive, one hand they push this way, one hand they push this way. See, they will do this way. Tell me, if they do this way, vehicle will take right turn or left turn fast. See, if they do this way, vehicle will take right turn or left turn. Common sense. First, vehicle will take right turn or left turn. See, for the wheel to take turn, that right turn it will take. Now, can you suppose same? See, you need both your hands. See, if I am driving here, if this is the wheel, what I should do? See, if this is the wheel, I will show the wheel here. Okay. See, this is the wheel. Usually, you turn this way. See, apply a force here, apply opposite force here. Correct? Okay. Now, by chance, you don't apply force here. You drive only with one hand. For example, only left hand. Right hand, you put on the what? Window. Some got the habit. Even I got that habit. When I go for drive, usually I don't drive this way. No. I drive that way only for emergency. Otherwise, 99% case, my other hand will be on the window. There. I use one hand. By applying only one force, can you turn the wheel? Tell me. Can you turn the vehicle? Suppose only one wheel. If I turn, see, single wheel, one hand you don't use. Just one single hand. Can you turn the vehicle or not? First, driving, you know car driving. By single hand use, can you turn the vehicle? First, in a car, if you use only one hand for steering, yes, but it looks against the theory, yes or no? By one hand you can't give a couple. So how it is possible? Tell me. Tell the answer. Anybody can tell the answer? Using one hand you can drive. Correct. But it looks like against the theory. Why? To rotate, to create a couple, you require two forces. By one force, how you manage the turning? Tell me. Tell me. How you manage it? How you manage it? How you manage? You are applying only one force. Still vehicle will turn. It is against the theory. It is against the theory. Why? Single force cannot create a couple. To create a couple, to require two equal opposite forces. No. Answer is yes. Other force will be the reaction through what? Other force will be the reaction somewhere here. See, reaction here. Other force is the reaction through that shaft, or is it called shaft or hub, or that portion going there. When you turn this way, their reaction will come. But remember, now your arm become lesser. Therefore, turning is more easier if you use two hands or one hand. One hand you can turn. Someone will tell. This question somebody asked me, sir, only one hand I will turn, sir, but your theory is wrong. I told my theory cannot be wrong. Other force is there, you are not knowing. It is the reaction. Oh, yes, sir. Yes, reaction comes there. But now, arm will be lesser. Therefore, turning is easier if you apply both the hands. See, if you turn this way, easy. If you turn one hand, you need little more effort. Or remember, even if you turn by one hand, reaction will come here. So, now, so remember now, both compression, tension together only can create internal resisting moment. Only one force you cannot do it. So, for the beam cross section to develop the resisting moment, compression, tension both are required. And moment of resistance, internal resisting moment equal to either C into lever arm or T into lever arm. Not C into A plus T into A. Like front wheel going 60, back wheel going 60, vehicle speed is not 120, vehicle speed is 60 only. Okay, now A is ordinary section, B special. Now there is a rule. What rule? See, one is compression, tension, both are coming. Rule is that, see here, even here you can see here, sigma 1 equal to sigma 2 into something. It is not equal because of unsymmetry. Here, unsymmetry because one is ordinary person, other is rich person. Their capacity wise, unsymmetry is there. But both should produce, together they should produce bending moment. So understanding is that whatever A eats here, B should eat same thing there. See, both should eat or drink. Drink bada bidi chanagirolla. Drink means people go to other conclusion. Okay, both should eat same items. You write here same items because, or when if a person who goes to ordinary section, that is self-service wing, he will tell in the coupon counter. See, communication is there. He will tell, give me 1 idli, 2 idli and 1 vada. B from the AC room should order for me also 2 idli and 1 vada. Over. A will tell, I want 1 kesari bath. B should tell, I also want kesari bath. Strict rules. How much A orders, B also should order same thing. Why? Together, one is eating here, one is eating there. Both are eating only. Item also is same. He is paying lesser because self-service. He is paying more because costly AC room. But kitchen is common for both. You see there, kitchen is common. They don't prepare 1 idli, 1 dosa for self-service. He won't tell. He will just announce, this is the item required. Or 3 coffee. He will not ask, coffee where? 3 coffee, that's all. So whatever this person orders, same this person should order. Understanding. Because together they will create resisting moment. Yeah. Now tell me, correctly answer. See, remember now, this is double. AC room is twice the cost. I will not tell again. AC cost is twice. If cost is X here, it is 2X here. If cost is Y here, it is Y by 2 here. I think sufficient if I tell that much. How much self-service costs, AC cost is double. How much AC costs, self-service is half. Okay, now start. Imagine 3 cases now. See here, A and B. How much money they are having? A has 200 rupees and B, A and B. See, A and B. B is rich. A is middle class. Okay. A has 200 rupees and B has, say, 1000 rupees. Tell me, what is the maximum money A can spend? Fast answer. How much A can order? Now, A can order how much he can eat for how much money? Fast, tell the answer. A has 200 rupees, B has 1000 rupees. Okay, now tell me, how much food A can order for? 200. Tell me now, how much food B can order? How much food B can order? Fast. How much food B can order? This much difficulty. Money matter. You can take, anybody in the road will tell the answer. Somebody on the road will tell the answer. How much A is buying by coupon, token. B is ordering 1000 rupees. What is this? I am going to close the class. You are not following what I told. 1000 rupees. Very good. That is the spirit. This much I explained and you are not following anything. Sorry. Class should be closed. I told there is an understanding is there. How much A, what all A will order, B has to order same thing. Whatever A will order, B has to order same thing. He cannot take anything extra. He cannot order less. A takes dosa, B should take dosa. A will take, I want 1 idli, B should take idli. Then A will tell, I want grape juice. He should not order mango juice. He should order grape juice only. Both orders should be same. Yes, now answer came. B can order for A. See, now A can order, I'll use red color, 200 rupees. Then B can order only 400 rupees. Even though he has got 1000 rupees, he cannot order 1000 rupees, because if he will order 1000 rupees, tell me how much A has to order then. If B uses the full money and he will tell bill some costly items, he will go for 1000 rupees what bill. Then tell me how much A has to order. How much A has to order? 500 rupees. He does not have 500. So after 200 rupees reaches, mutual communication. Imagine. See, liver arm is the liver in the beam liver arm. Here link is there. B will keep on seeing what A is doing, or A will send a message to B. I ordered dosa. B will tell, waiter, one dosa. With dosa. He will tell rava dosa. Waiter, for me also rava dosa. A will tell butter required. B also will tell butter required. Same thing. One paisa should not change. So therefore, tell me here, for this case, what is the maximum limit for A? Answer. For this particular case, what is the maximum limit of spending for A? Answer. Fast. What is the maximum limit of spending for A? Maximum limit of spending for A. A means ordinary person, 200. What is the maximum? B, he can pay, he has got a permissible limit of 1000. Even though he has 1000 rupees in the pocket, maximum money limited or maximum limit for him, how much? For B, maximum limit for B. He may be having more money, but no use. What is the maximum limit for B? 400 rupees, correct? In RCC, if B is steel, if A is concrete, this is called over-reinforced section, correct now? Over-reinforced section means steel is provided in excess than required. Now clear? In RCC, when steel is predominantly provided where it cannot be fully stressed, or area of steel available is more than that required for balance section, it is called over-reinforced section. If you connect it to RCC, this is like over-reinforced section. Clear now? Clear or not? It is equivalent to over-reinforced section. Okay, now one case over. Second case. Okay, now one chance over. Tell me. Second chance. Imagine A has got 1000 rupees and B has got, he is rich no doubt, 1800 rupees. Tell me, fast, what is the maximum bill A can order? How much A can spend? Fast. Second case, A has 1000 rupees, B has 1800 rupees. Tell me, what is the maximum money A can spend? Answer. What is the maximum money A can spend? A can spend 900. Yes, he can spend only 900. Why? Because when his bill comes to 900, here bill will come 1800. Then this B will tell, stop. Further, I don't have money. But A will tell, I have still 100 rupees left. Okay, nothing can be done. No, don't order further. So this is where stronger is critical. In RCC, this is equivalent to what section? Tell me. In RCC, this is equivalent to what section? Where steel cannot be fully, where concrete cannot be fully stressed. Steel you can use full, or steel is critical. It is equivalent to over-reinforced. Over-reinforced. when this is over-reinforced. What is this? Over-reinforced, this one. Stress in steel is limited. Concrete is free. That is, there is shortage of steel. How it came over-reinforced? After all this example, how it came over-reinforced first of all? It is equivalent to under-reinforced section. Or, see here, A has 1,000 rupees, but he cannot pay 1,000 because if he orders 1,000 rupees, B has to order for 2,000 rupees. No, he does not have 2,000. He has only 1,800. So B will tell, when the ordering reaches a stage, when his bill comes to 1,800, he will signal to A, hello A, please stop eating. Why? My money is fully gone. If you order further, I cannot order. But as per rules, he has to order. Why? He has to order. See, this is to be followed. Relation between sigma 1, sigma 2 is condition. I told you, see, irrespective of whether you are going for, I told something, stress calculation or later moment of resistance or permissible stress, whatever you do, this condition should be satisfied. Therefore, now last time A has 200, he can spend 200. B has 1,000, he cannot spend 1,000, he had spent only 400. Here, A has 1,000, B has 1,800. B maximum bill B can pay is 1,800. A, even though he has 1,000 rupees, he should not eat more than 900. So, limit for A will be only 900. He cannot use the full money with him. Okay, now, last case. Suppose A has got 600 rupees and B has got 1,200 rupees. Oh, what a coincidence. Tell the answer. Tell me, how much bill A can pay? Or how much order allowed for A? First, A has 600, B has 1,200. How much order A can go for? Maximum. What is the maximum order A can give? 600. How much at that time B has to pay? Or how much bill B can go up to? How much order B can go for? 1,200. When the bill for A reaches his money in his pocket, at the same time bill for B will reach his money in his pocket. When the compressive stress in concrete reaches the permissible limit for concrete in compression, at the same time tensile stress in steel will reach permissible tensile stress for steel. This is a coincidence. This is called what section? Tell me. In RCC, this is called balance section. See, in RCC, how you define balance section? A balance section is one where when the maximum stress in concrete in compression reaches the material, its permissible limit, that is sigma CBC, at the same time simultaneously stress in steel, tension steel, sigma steel will reach its permissible limit, that is sigma ST. That is called balance section. RCC class, I told clearly balance section. Further RCC I can't tell. Therefore, make a conclusion now. The firm conclusion now. When you have to see now, last statement, this is very important. If this is clear, we can continue this question and solve many questions, and I will not explain this much now. There is a limit. I will keep on doing question. Okay, see. Therefore, to find MR, use either MR equal to sigma 1 into Z1 or use MR equal to sigma 2 into Z2. If you use that way, sigma 1 is maximum permissible stress at the top fiber. top fiber. Sigma 2 is maximum permissible stress at bottom fiber. Bottom fiber, very important for that cross section. For that cross section. Fully clear? Now I will tell you what is the meaning of for that cross section. Is clear? Tell me. Either use MR equal sigma 1 into Z1, then sigma 1 is maximum permissible stress at the top fiber, or sigma 2 Z2 maximum permissible stress at the bottom fiber. For that cross section you round off 100 times this way. Very, very important. Now I will tell you that for that cross section means, I will tell you what. Sometimes it is, see, you should write down. See, sometimes or many times it is possible that the strength in tension and compression are not same. They are different. Even if it is same, the stresses developed may not be same. Why? Unsymmetry. It depends upon Y1 and Y2, or your sigma 1 by Y1 equal to sigma 2 by Y2. This condition is to be satisfied, or you can tell sigma 1 equal to Y1 by Y2 into sigma 2 Y2. Sigma 1 is Y1, or you can tell sigma 2 equal to Y2 by Y1 into sigma 1, or this is equivalent to our money matter twice the bill. It is not twice here, it is equivalent to our money matter twice the bill. Twice is just to understand a given, easy to calculate. So that this relation finally we got here. See, we got here. This is we got by what? This we got by sigma 1 divided by Y1 equal to sigma 2 by Y2. See here, sigma 1 divided by Y1 equal to sigma 2 by, why should I write? Yesterday I wrote it. I first wrote that way, simplified. Why should I write once again? So this we got by bending stress distribution pattern across the cross section. This will tell you, if this will give you, if you know what stress comes at the bottom fiber, then how much stress will come at that time for the top fiber. Or this will give you, if you know what stress comes in the bottom fiber, what stress comes in the top fiber, or at that time how much stress will come in the bottom fiber, or these both are same. This will give you, if the stress reaches a particular value at one of the fiber, then at that time, how much stress is developed at the other side fiber. So therefore, when you want to find MR, you should correctly observe. See, when you find MR, it is very important that nowhere stress should exceed the limit. Nowhere stress should exceed the limit. And also MR means maximum BM. So at least in one place stress should reach the limit. See here, money matter. First example, A will collapse, A will reach the limit, B will not reach the limit. Second case, B will reach the limit, A will not reach the limit. Third case, special case, both will simultaneously repeat. Or you write big letter here. See, I am not writing here. Those who are serious write here. When you find MR, stresses should not exceed the limit, and at least on one side stress should reach the limit. But when on one side stress reaches the limit, other side should not go beyond the limit there. When you consider stress on one fiber equal to limit, other side it should not go beyond the limit. Then only section is safe. When you tell MR, it indicates that much BM is safe for the cross section. All the statements what I told, including money matter, everything you write repeatedly, go through again and again. All the statement go through again and again till you get complete mastery. Agreed? Till you get complete mastery, go through all the statement, then only you will understand the problem. Otherwise, it will result in nonsense answer. Agreed or not? All this I will not see. If it is an offline class, I tell this 4 or 5 times, the statement. Now only once because recording is there. Agreed or not? Okay. Now I will start numerical. Silently start the question. Now I will not explain much. Someone will imagine, someone joins the class now and he will tell the MR part is not clear. You are not explained. I will tell, leave my class. Don't once again click my channel. Why? I explained everything. No, that I have not gone through. I want only problem. If you want only problem, go somewhere where people are there. They will do the problem. Only problem. That sometimes that also wrong only. Okay, start. Now part 2, question 1. Part 2 connected MR. Part 2, question 1 is, 1 minute. Part 2 is, 1 minute now. Part 2 full question is find, okay. Your part 2 is completely everywhere question is find MR. Find MR. Or remember now, clear? Your part 2 full now. How many questions I don't know. I will solve till I feel that what? Everything is clear. I should be sure 100% coverage should be over. When I feel 100% over, I will stop this question. So till that time, part 2, whatever I ask now, whatever I give, question is, every question starts from find MR if I will keep on writing here, if. See, question number 1, question number 2, question number 3, if I will give. Clear now? So every question I give, question is find MR if. Okay, start. I won't waste time now. Question number 1. If I told question is what? Find MR. I am going for part 2. Part 2. Find MR. Okay. If permissible allowed limit not to exceed all are same. See, sometimes people will tell, sir, you told permissible. What happened? Exam they give allowed. I will tell, don't write the exam. You keep on writing examination till one fine day they use the word permissible. Sir, it may take 10 years. Well, no problem. Write exam. Every time see the question paper. If they use the word allowed, don't write the exam. Why? Because you know only permissible. Permissible, allowed, or what you call not to exceed, limited to, all same meaning. Permissible speed 60 kmph, allowed speed 60 kmph, maximum limit for speed 60 kmph, speed should not exceed 60 kmph, all are same meaning. Okay. Permissible bending stress. See, they told bending stress. They have not bothered for tension compression. Bending stress is randomly 150 Newton per mm square is the question. First tell me MR. I want MR now. Answer. In kilonewton meter. You should solve by both. See, solve by both. Both means what? You find MR by using sigma 1 Z1 and also use MR equal to sigma 2 Z2. Both should give same answer. In my class, when you find MR either based on compression or tension, answer should be same. If answer is not same, that is the last day of my class. I will not teach 1 millimeter from then onwards. I will take a small 5 minutes break now. Tell the answer first. Fast calculate. Okay, 5 minutes break for me. I want to see how much you understood now. That you should solve the question by both expressions. You should find, see, every question if I now onwards. That's why I told this class is required for tomorrow also. Once for all settlement it is called. It is called settlement once for all. Every time you solve the question, one solve by using MR equals sigma 1 into Z1. Then solve the question by using sigma 2 into Z2. Both should give same answer. Different answer means I will not come back once again. Start. You should tell answer is same for both. Fast solve. I will take just 5 minutes break. Okay. We'll start. Not much work is there. Voice all clear? Just comment. Any problem? I think no problem, I think. Okay, clear. The board, the disturbance all, I am removing next week after coming from native place. I will put a white covering here so that I don't like that extra portion there. I want to somewhat decent appearance. I can go for it only after covering the board. If you see some white background, okay. Otherwise, or I should change the board size exact to fit into YouTube. Voice clear? Any problem for voice? This is to confirmation. Voice clear? Fast. Now I will explain the question now. See, every time money matter will come. Some will tell money matter why he is bringing. They will. Then I will ask some question with them. Within no time, they will start making mistakes. Then I will tell. Now tell money matter required or not required. Money matter is only temporary to understand the concept. Even if I am solving, I don't require money matter example. I will not think if A is paying 100 rupees, what we will do. See now, find MR. See, I will write here now. Solution 1. Find MR by MR equal to sigma 1 into Z1. Okay, I will solve it here. And then I will remove this one. I will put the solution 2 here. See, space is there. Solution 2. Solution 1 beta. Solution A. Sub-solution. Solution B. For first question, find MR by the equation MR equal to sigma 2 into Z2. Over. Now see, you have to write a statement here now. See now, statement you have to write. Correctly see now what you have to write. This permanently you have to write here. That is that double star. You should write that double star. This statement you have to write. We know that when sigma 1 reaches some value, at that time what sigma 2 will reach. Like when the bill in ordinary section reaches 50 rupees, AC bill will become 100 rupees. Or when AC room bill reaches 500 rupees, self-service side bill will reach 250 rupees. And both has to order same thing. Why? Both together create MR. Okay, start. Now, they told what? See, before starting, common statement. They told permissible bending stress is how much? See, I will write here now. Common statement, I will write here. See, common statement. They told permissible bending stress. Bending stress is how much? I forgot now. How much I told? Forgot. Ayyo. Forgotten. How much I told? What to do? Who can remember? How much I told? Permissible bending stress. How much I told? Some number I told. The permissible bending stress, I told a number. I don't remember how much it is now. Completely forgotten. 150 Newton per mm square. Okay. 150 Newton per mm square. Means, right, they are not bothered about tension compression. They told bending stress should not exceed 150. Means what? Neither at top fiber nor at bottom fiber should exceed 150. Neither the AC room bill nor what? No, not that way. Neither here nor there. They told 150 rupees to be exceeded. Ordinary person, bill should not exceed 150. And AC room, there also, bill should not exceed 150. Now tell me, should not exceed 150 they told. But we are not, no, it is not that way. They told permissible bending stress is 150. Okay. They are not told where. Neither here nor there. it should exceed 150. Now, see correctly. Sigma 1 is 133 by 117 of sigma 2, means sigma 1 is more. In this example, I will give one series homework where it is inverted. Means what? I will see that neutral ax will shift further upward. Then sigma 2 will come more than sigma 1. Full homework I will give you. Work out that question. Okay. Therefore, neither in what? Neither in AC room nor in what? This room, bill should exceed 150. Now tell me, where bill can reach 150? In AC room or ordinary section? They told not more than 150. Means, tell me, where bill can reach 150? Neither in AC room nor in self-service side. Bill should not exceed 150. So tell me, where bill can reach 150? Fast. Where bill can exceed 150? Or where bill can reach 150? Fast. Neither in self-service nor in AC. Both the places, bill should not exceed 150. Means, common sense. Tell where? Where? You are not answering the question. Think a little, money matter only. Where 150 you can reach? No. You tell this answer. AC room or self-service? AC room or self-service? Where? Tell me. AC room or self-service? Where bill can reach 150? In CS means, what is CS? CS means what? I don't know if it is CS means. What is CS? AC room, correct. Why? Because if the AC room is 150, self-service bill will come 75. Okay, done. Suppose self-service bill comes to 150, tell AC bill. If self-service bill comes 150, tell AC bill. Tell AC bill. Tomorrow when I continue, some will ask, what is AC, what is self-service? I will tell, leave the class. If they comment here, I will tell, leave the class. I am harsh in that matter. Later if comment comes, I will tell, don't come to my channel. Tell me, if the self-service bill comes to 150, how much AC bill will come? No, less than 150. What is this? What is this? From where you get this idea? If the self-service bill come to 150, AC will come less than 150. What is this idea? How you got, first of all? If the AC bill 150 means self-service 75. Okay, no problem. If self-service bill come to 150, what is AC bill will come? Very purpose of the question only not understood. If self-service person will order for 150, tell the bill in AC room. Bill in AC room how much then? I never thought this much difficulty for such a simple question. It is somebody on the road will answer by this time. If the AC person bill come to 150, okay, then self-service bill will come 75. Okay, no problem. How much it will become? How much it will become? If the self-service person makes a bill of 150, AC bill will come 300. How we can pay 300? Condition, neither in self-service nor in AC, bill should exceed 150 means what? AC bill should not exceed 150. Or see, sigma 1 and sigma 2 both are there. Here tell me, which is more? We know that sigma 1 more or sigma 2 more. Tell me answer here. See the relation here. We know that. See here. Sigma 1 more or sigma 2 more. Sigma 1 is 1 point something of sigma 2. Sigma 2 is point something of sigma 1. Which is more? Which is more? Sigma 1 or sigma 2? Which is more here? In our question, AC room is sigma 1. Which is more here? Where test will come more? Top or bottom? Sigma 1. Therefore, here 150 means, see, we know that sigma 1 is more than sigma 2. Why? You can write sigma 1 is how much? 133 by 177 of sigma 2. Therefore, sigma 1 to be limited to how much? Limited to 150 Newton per mm square. Then what is sigma 2? Tell me. Then what is sigma 2? See there, sigma 2 equal to 1, sigma 1 equal to 133 by, what is sigma 2? Sigma 2 equal to 117 by 133 of sigma 1. Sigma 1 150 means, what is sigma 2? Tell me. What is sigma 2? Tension compression does not matter here. Tension compression does not matter here. How much sigma 2? Tell me. How much sigma 2? When sigma 1 reaches 150, how much is sigma 2? Don't buy our sigma 1, sigma 2. In this question, sigma 1 more. How much sigma 2 then? When sigma 1 reaches 150, how much is sigma 2? Again, you are wasting time. Substitute there and tell the answer. Substitute and tell the answer fast. Substitute and tell the answer. What is sigma 2? You are wasting lot of time. See, such a waste of time is problem. 190. What is this one? I think better stop the class now. 117 by 133 of 150 is 199. What is this happening first of all? How these answers are coming? First of all, which is the calculator you are using? Any working calculator? Country I will not tell. I feel like telling a country, but I don't want to tell, comment that way. 131.9548. Sigma 2 is 131.9548 Newton per mm square. So right here, see, if you substitute sigma 1 equal to 150, then sigma 2 is, you get what? 133, which is okay. Okay. Now, right here, by chance, if we consider sigma 2 equal to 150, tell the answer. Then what sigma 1 will come? Tell the answer. By chance, you consider sigma 2 150, in a hurry to calculate. Sigma 2 150, then sigma 1 will come. 133 by 117 of sigma 1. Tell the answer. Then how much sigma 1 will come? Suppose by mistake they told bending stress, you randomly consider sigma 2, just like that. Then if you substitute sigma 2 equal to 150, how much sigma 1 will come? How much? Answer. How much sigma 1 will come? Now it is correct answer. What you told earlier. 170.5128. It will come 170.5128, which is more than 150 is the limit. They told neither in the top fiber nor in the bottom fiber stress should not exceed 150. Therefore, if you find MR equal by sigma 1 Z1, you substitute sigma 1 equal how much? Here, substitute sigma 1 equal to 150 Newton per mm square. Then MR equal to 150 into Z1. Hey, Z1, come here. 2.41603 10 to the power 6 Newton millimeter. Tell the answer in kilonewton meter. Tell the answer in kilonewton meter. Because when you substitute sigma 150, then we know sigma 2 is less than 150. Okay. It is less than 150. Therefore, okay. Answer. MR. Fast. MR answer fast. See, if you do this way, tomorrow's class also not sufficient. Then I have to extend the YouTube class for one more day. No. Tomorrow I want to close the YouTube. Because from Tuesday onwards, class will continue in Zoom only. I told the reason for it. People don't deserve. They don't deserve. Or, I will ask a question. Tell me a place where this much of information is given for MR. Okay, let me see. Let me see where in the entire world I will tell. Entire world. Show me one lecture where this much explanation is given for MR. Show me a place or any, you tell me, send me a link for find any YouTube class where, any class where how much I explained more than that explanation and much more clear and much more concept based and much more powerful way of understanding. You show me one place sufficient. One place you show me. One place. Let me see. Where is it? 362 point. How much? 362 point. 40 kilonewton meter. This is the MR right here. If this much bending moment is applied, then stress at the top fiber will reach 150. Stress at the bottom fiber will be how much? You told 100. Where is the answer? 131.954. So both the edges stresses are not beyond the limit, whereas one side it reached the limit. So this is MR. Or now, or if you find MR by sigma 2 Z2, see here what I am doing. Sigma 2 Z2. Suppose we consider sigma 2 equal to 150 Newton per mm square as per data, as per question. Then your sigma 1 will reach, this is the bottom fiber stress. Stress at top fiber will reach how much? 133 by 117 of 150. That is equal to how much? 170.512 Newton per mm square, which is more than 150, because in the question they told bending stress is not to exceed 150. Therefore, sigma 2 equal to 150 is not allowed. You should reduce sigma 2 so sigma 2 is to be reduced so that for that sigma 2, sigma 1 should not exceed 150 Newton per mm square. That sigma 2 is what? 150 into 117 by 133 equal to, how much you told answer? Forgot that answer. 131.9548 Newton per mm square. Therefore, your MR will become sigma 2 into Z2 means 131.9548 into Z2 is 2.74613 10 to the power 6. Tell, this is Newton millimeter. Tell the answer in kilonewton meter. If not same, tomorrow onwards, no class. If not same, tomorrow onwards, no class. Neither in YouTube nor in Zoom. You can, someone will tell, KSN stop the classes. Why? Because his concepts are found to be wrong. Answer. Someone will tell you. It is same answer. 362.40. Over. That's all. Over. Now, I thought I will do 3-4 cases. Tomorrow, 1 or 2 questions, I will this way only explain for you. Going round and round. Then onwards, I will put the condition here. We'll go that side. Come in 2 minutes. You should tell the answer. That way, tomorrow we will try to close this MR calculation for this critical question for MR. This will help you for RCC also. See, now by this example, you can understand the behavior in RCC also very thoroughly, or anywhere in structural engineering when the bending stress distribution is known and when the stresses are different or anything, different materials or unsymmetrical section, how to control the stresses, you will completely know it. Earlier, remember, I gave some other money matter. Today I decided to give this money matter. I think this money matter is better. There, I used to ask how much total we can spend. No, here how much he will eat, same he also will eat. By MR is constant. Okay, thank you. So you'll see tomorrow. Tomorrow we hope this chapter, this MR part will be over. Then from Tuesday onwards in Zoom, I'll continue remaining of bending stress. Lot of concepts are there. Bending stress, shear stress. Then I'll go to deflection, and then other subject of some deflection columns. Then structure analysis. That will continue from next class, from Tuesday onwards in Zoom. Tuesday will be the native place, no problem. Function is on Monday. Tuesday I am free. Tuesday I am free. I will come back most probably on Friday or Saturday. In case I come back on Friday, one problem. If my day journey is on Friday, then that day not possible. I will let you know on that day. Because when I come by Saturday, I have to reach here. Because Sunday, software class is there. Okay, thank you.